Okay, we're going to be multiplying radicals, and the biggest rule is that as long as the index are the same to the radicals, you're allowed to multiply them and put them into one radical. And you can go the opposite way as well. If you have one radical, you can split them into two that are being multiplied. So first one, just going to ask, can you simplify? So can I multiply the cube root of 6 times the square root of 2? And that would be no, because the roots are different. The indexes are different. The next one, the cube root of 4 times the cube root of 2. Yes, I can simplify that, and that becomes the cube root of 8, which then in turn becomes 2. Okay, we're going to discuss simplifying a radical. And we've done the square roots before, so that's not anything new. And you're going to do all the other radicals pretty much the same way. If you use the factor tree or the birthday cake method, it's all the same. So I'm going to do both here for the square root of 24. Remember the birthday cake, they all have to be prime numbers. I divided by 2, that becomes 12. Divided by 2, that's 6. Divided by 2, that's 3. Divided by 3, and that's 1. And remember you had a pair of 2's, so a 2 comes out, and I have square root of 2 times 3, which is 6 on the inside. If you did the factor tree, it's the same thing. You can do it into 6 times 4, 3 times 2, 2 times 2. You have a pair of 2's. That goes on the outside, 2 times 3 on the inside. 2 times square root of 6. All the other radicals are very similar. You can still use those same methods. So I'm going to do the birthday cake. Same birthday cake, ends up being the same way. The only difference is, because it's not a square root, it's a cube root, I'm not looking for pairs to circle and bring one out. I'm looking for 3 of a kind. Because this is a cube root, I got to look for 3. If it was a 4th root, I'd have to have 4 of the same number. So here I have 3 2's. So 1 2 comes out, and what doesn't have a triple or a set of 3 is that 3, and that would stay on the inside. So it's 2 times the cube root of 3. You do the same thing with the factor tree, except you're looking for triples, so it would be 3 2's, and the same idea. And when it's a variable, very similar to 6.1 that we did today. Okay, divide it. But in these, they don't go in evenly all the time. So 14 divided by 3. Well, 3 goes into 14 4 times. So that means x to the 4th is going to come out. But when I multiply 4 times 3, that's 12, not 14. So that means that there's 2 remaining. So what it means is that remainder is going to stay on the inside of that radical. So that's going to be x squared. So 3 goes into 14 4 times, but it has a remainder of 2. So the 2 stays, the x squared stays on the inside. So here I have the cube root of 54x to the 5th. So I can split that into the cube root of 54 times the cube root of x to the 5th, and then simplify each of these separately like we just did in the last 3. So if I do the factor tree, I'll do the factor tree for this of 54. I'm going to use 9 times 6. 9 factors into 3 times 3. 6 factors into 3 times 2. So what that means I'm looking for 3 of a kind because it's a cube root, so I have 3 3s. That means a 3 comes out, a 2 is left on the inside of that radical. So to do the x to the 5th, 3 goes into 5 once, so that means an x comes out of the radical, and it would have a remainder of 2, so that means x squared is left on the inside. So what I have is 3x on the outside times the cube root of 2x squared. And that would be my simplified form. Okay, so here I have 2 radicals being multiplied together, and because they're both square roots, I can combine them. So what I'm going to do is multiply them together, and it's going to be 72 times 10, which is 720. X to the 3rd times x to the 1st, and remember that's the rule, we add the exponents, so that becomes x to the 4th. Y to the 2nd times y to the 3rd becomes y to the 5th. So it's the square root of 720 x to the 4th, y to the 5th. And now I can just simplify this just like we did the one before. So I'm going to do the birthday cake this time with 720 and divide it by 2, and I get 360. Divided by 2, I get 180. Divided by 2, and I get 90. Divided by 2, and I get 45. I can divide that by 5, and that's 9. 1 second. I'm running out of room, so I move it a little bit. So divide 9 by 3, and that's 3. Divided by 3 again, and that's 1. So because it's a square root, I'm looking for pairs only. So I have a pair of 2s, another pair of 2s, and a pair of 3s. So what that means is what's going to come out is 2 times 2 times 3. The 5 is left on the inside. So when I'm doing the square root of x to the 4th, 2, this is an index of 2, so 2 goes into 4 twice. So that means an x squared is going to come on the outside. Let me just write that here. We'll put it together later. And the square root of y to the 5th, that means there's nothing, sorry, on the x there's nothing left on the inside. Because it went in evenly, there was no remainder. So there's nothing left on the inside. And then the square root of y to the 5th, 2 goes into 5 twice, so that's y squared. And what's left on the inside is y to the 1st because there was 1 remainder. So I'm going to put them all together. 2 times 2 times 3, that becomes 12. I have an x squared, a y squared on the outside. What's left on the inside of the radical? I have the 5 and the y. There's no x because the 2 went into 4 evenly. And that's my answer. Okay, so here's a couple you tries. Take some time and try these. And come to class with these finished, and we'll go over these first thing if you have questions. Okay, here's a joke. What's red and green and goes at 80 miles an hour? A frog in a blender. Oh, maybe I shouldn't have done it. I'm getting a little rusty. I'll get back there. Sorry.